So in this session, we will take a look at how to find the number of divisors of a given number and some variations of this question. So if n is an integer greater than 1, then n can be broken into its prime factors. We all know that. So n can be broken as a to the power p into b to the power q into c to the power r, which are the prime factors of n. So you can see that ABC are prime numbers or prime factors of n, and PQR are the natural powers of these prime factors. The number of divisors of the number n are given by a very simple formula: D is equal to P plus 1 into Q plus 1 into R plus 1, and so on. So if there are more number of prime factors, we can keep on adding these brackets here. So let us solve one question. Calculate the number of divisors of the number 48. Now for 48, we can actually calculate the number of divisors very easily by listing them down. But for larger numbers, the formula would help. So let us factorize. That's our first step. Factorize 48 as 2 to the power 4 into 3. So if we factorize 48, we will get this particular factorization. So what is the value of P? P is equal to 4. And what is the value of Q? Q is equal to 1. So number of divisors of the number 48 is given by 4 plus 1 into 1 plus 1. That is equal to 5 2s are 10. So we saw that by this simple method, by this simple formula, we can calculate the number of divisors for any number. Now where did that formula come from? See, this is very important point to note, that how the divisors of 48 are made. The divisors of the number 48 must come from its prime factors, and therefore we can say that the divisors of 48 must come by combining one or more of the prime factors of the number 48. Once again, we write the prime factors of 48. 48 is equal to 2 to the power 4 multiplied by 3. So we see there are 4 2's and 1 3 in the prime factorization of 48. So divisors can be obtained by combining 2's and 3's from the available 2's and 3's in the prime factorization of 48. So how many 2's are there in 48? There are 4 2's and there is only 1 3. So let us see in how many ways we can combine the available 2's. So from the 4 given 2's, we can choose 0 2's, which is represented by 2 to the power 0 there, or we can select 1 2, which is represented by 2 to the power 1, or we can select 2 2's, which is represented by 2 square, or we can select 3 2's, which is represented by 2 to the power 3, or 4 2's, which is represented by 2 to the power 4. So we see there are 5 ways of selecting 2's. Either we don't select a 2, or we select 1, 2, 3 or 4 2's. Similarly, we have for the prime factor 3, we can select it in 2 ways. Either we select 0 3's, which is represented by 3 to the power 0, or we have 1 3 selected, which is represented by 3 to the power 1. So we can select the 3's in 2 ways. We know that in mathematics, every OR is replaced by a plus sign and every AND is replaced by a multiplication sign. So we have 2 to the power 0 plus 2 to the power 1, because the OR above is replaced by an addition sign, plus 2 to the power 2 plus 2 cube plus 2 to the power 4. The AND is replaced by an into sign, and we have 3 to the power 0 plus 3 to the power 1. So we see those arrows represent that the OR has been replaced by a plus sign and the AND has been replaced by a multiplication sign. So you'll notice that the number of divisors is the number of terms in the expansion of the brackets below. There are 5 terms in the first bracket, which is represented by P plus 1 in the formula, and there are 2 terms in the second bracket which are represented by Q plus 1 in our formula. and we get the answer, the number of divisors as p plus 1 into q plus 1. Next, how to calculate the number of odd divisors of a number? If n is an integer, again, the number of prime factors of the number can be written as n is equal to 2 to the power p into b to the power q into c to the power r. And you would appreciate that if n is an even number, we will have some value for p. And if n is an odd number, then p should have the value 0. P should assume the value 0. Because there will be no even prime factor in the expansion of an odd number. Again, ABC are prime factors or prime numbers, and PQR are the natural powers of the prime numbers. So number of divisors of this number is given by q plus 1 into r plus 1 and so on. We should just ignore the prime factor 2 and apply the same formula as we've learned previously and solve such a question. So consider all prime factors of n except the prime number 2, as I've already told you. Let us take a look at one example. Find the number of odd divisors of the number 120. So 120 can be broken into its prime factors as 2 cube into 3 into 5. To find the number of odd divisors, ignore the prime factor 2 and apply the same formula. So q is equal to 1, that is 3 has a power of 1, and r is equal to 1 because 5 also has a power 1. So number of odd divisors is given by q plus 1 into r plus 1, which is 1 plus 1 into 1 plus 1, which is equal to 4. So there we have a very simple method of finding the number of odd divisors of the number 120. Now how to find the number of divisors of 420 which are multiples of 5? Again, the first step is always prime factorize. So we have 420 is equal to 2 square into 3 into 5 into 7. This is the prime factorization of 420, which is always our first step. So here we have the power of 2, p, is equal to 2. The power of 3, that is q, is equal to 1. The power of 5, that is r, is equal to 1 again. And the power of 7, that is s, is also equal to 1. Since we are looking for multiples of 5, just take out 1 5 from the prime factorization. We are looking for all divisors that are multiples of 5, so we just want to take out 1 5 from the prime factorization of 420 as represented below. So we have 420 is equal to 2 square into 3 into 5 into 7. Just ignore that 5, and which means we can assume that r does not exist. R is the power of the prime factor 5. And now apply the same formula. The number of divisors of 420 which are multiples of 5 is equal to p is equal to 2, so 2 plus 1, q is equal to 1, so 1 plus 1, and r has been ignored. We also have s is equal to 1, so we have another 1 plus 1 there. So we have p plus 1, q plus 1 and s plus 1 being represented as 2 plus 1, 1 plus 1 and 1 plus 1 below. On multiplying this, we will get 12 as the answer. So number of divisors of 420 which are multiples of 5 are 12. If we were asked for multiples of 7, then we would have ignored s, and that is all prime factors of 1 7. We would have ignored 1 7 from the above prime factorization. So with this, we come to an end of this session. In case you have any feedback or in case you have any query, please feel free to write into us on studentservices@pfindia.com. Thank you very much.